So for our last example in this series, we're again going to look at an improper integral with a vertical asymptote. And we say, well, where's the vertical asymptote? Obviously, 1 would create a 0 in the denominator. So we have a vertical asymptote at 1. And we see there's going to be a discontinuity on our interval from 0 to 3. So again, let's look at the graph. So we're looking at evaluating this integral from 0 to 1. We're going to have to break it because of the discontinuity, and then from 1 to 3. So I'm going to set this up, and I'll say here that this integral, when I split this, is equal to the integral from 0 to 1 of dx over x minus 1 to the 2/3 plus the integral from 1 to 3 of dx over x minus 1 to the 2/3. So we have case 2 of our definition for type 2 improper integrals, and then as well we have case 1. So when I set this up for case 2, this first part, b is my discontinuity. So I'm going to set this up and say, well, this is going to be the limit as b approaches 1, and we will be approaching from the left-hand side of the integral from 0 to b dx over x minus 1 to the 2/3 plus, in this case, the discontinuity is occurring at a, so we'll say the limit as a approaches 1, and we would be approaching from the right-hand side, and that would be the integral from a to 3 of dx over x minus 1 to the 2/3. So these can both be integrated by a u substitution. So I'm just going to do that as some scratch work here. So if I was dealing with the integral of 1 over x minus 1 to the 2/3 dx, I would let u equal x minus 1. That means that du equals dx. So this is the integral then of 1 over u dx. And that would be 1 over u to the 2/3. So that's the integral of u to the negative 2/3 dx. And applying my power rule for integration, if I add 1 to negative 2/3, I get positive 1/3. So dividing by positive 1/3, I have 3u to the 1/3. Okay, so that's going to be plugging my u back in. That's going to be 3x minus 1 to the 1/3. So here I have the limit as b goes to 1 from the left of 3 times x minus 1 to the 1/3 power. We need to evaluate that from b to 0, plus the limit as a goes to 1 from the right. Again, 3 times x minus 1 to the 1/3. We need to evaluate that between 3 and a. And this piece, we've got -3. Since this has all numeric values in it, we can simplify it. That is -1 to the 1/3. The cube root of -1 is -1. So this value right here is going to go to 3. So I've got the limit as b approaches 1 from the left, and I'm noticing I just did that again. That should just be a negative up here. We've got 3, b minus 1 to the 1/3 plus 3, plus the limit as a goes to 1 from the right of 3 times 3 minus 1 to the 1/3 minus 3 times a minus 1 to the 1/3. So as we continue working through this first number becomes 3 times the cube root of 2. So I'll rewrite what we're dealing with. We're dealing with the limit as b approaches positive 1 from the left of 3 times b minus 1 to the 1/3 plus 3 plus the limit as a approaches positive 1 from the right of 3 times the cube root of 2 minus 3 times a minus 1 to the 1/3. All right, so we have to look at what happens when I plug in a number slightly to the left of 1. So if we consider that slightly to the left of 1, that could be 0.999. And if I were to plug that in here, I would have 3 times 0.999 minus 1 to the 1/3 plus 3. So this is going to be, inside my parentheses, a very small negative number. So I have 3, 0, and we'll say, I'll write it this way, v small negative cube root of that plus 3. And the cube root of a very small negative is also going to be a very small negative number. So it's essentially saying like 3 times negative 0 plus 3. And we get the limit for this first part is positive 3. By a similar argument on the right-hand side, we're going to end up with something that looks like 3 cube root of 2 minus 0. And in this situation, that's just going to give us, we get plus 3 times the cube root of 2. So those are both finite values, and the sum of two finite values is also a finite value. So I've got 3 plus 3 times the cube root of 2. This improper integral converges to this finite value to determine the area under the curve from 0 to 3 of this rational function. As always, please email me if you have any questions.